So for Lab 4, it's about first order circuits, and for part number 1, it's about RC circuits, the differentiation, where it's an R in series with a capacitor, and the input voltage is a square wave, and the output is across the resistor. So I chose 3 resistors, 560, 1K, 1.2K, 3 capacitors, 3.3 nano, 6.8 nano, 15 nanofarad, and then tau for RC circuits equals R times C. So this is tau for the first circuit, tau for the second circuit, tau for the third circuit. And here's the circuit. Here's the first circuit. This is the 3.3 nanofarad in series with the 560. 560 is connected to the ground. And this is the BNC to banana cable is coming from the function generator, and it's connected to the capacitor. And this is connected to the ground. Also, this is the 10-to-1 probe, and it's connected it's measuring the output across the resistor. So for this circuit, we'll need the function generator, and we need the oscilloscope. For the function generator, we need to set the voltage to a square wave, 2 peak to peak, and instead of setting up the frequency, we'll set up the period, and the period should be 12 times the expected tau for the circuit. So first step, so the amplitude is 2 peak to peak, and it's a square wave, and instead of setting up the frequency, we'll set up the period, and it should be 12 times the expected tau. For the first circuit, R is 560, C is 3.3, so tau is R times C, 1.8 microseconds. 12 times tau equals 22.1 microseconds. So 22.18 microseconds. And then apply signal. For the oscilloscope, the function generator is connected using a T connector and a BNC to BNC cable. The function generator is connected to the oscilloscope through channel 1, and then channel 2 using the 10-to-1 probe is connected to the circuit, and it's across the resistor. So for channel 1, this is the square wave coming from channel 1, and this is the output of the RC circuit, the differentiation. Now for the time constant, so the time constant is the time required for a response to decay to a factor of e to minus 1, or 36.8%. So the amount of decay equals 1 minus e to minus 1, which is 63.2%. So we want to get this response from the oscilloscope, and then use cursors, 2 cursors, cursor x1, put cursor x1 at the very top, and put cursor x2 at the very bottom, and then read delta y, which is the peak value of the voltage, then multiply delta y by 0.632, and then move cursor x2 from this point to the value of v peak times 0.632. Then delta x is tau. Now this is the same as the response here. We want to get to this point. And delta x here is tau. So let's get back to the oscilloscope. So we want only one of these. So let's turn channel 1 off. And then maximize one of these. Let's move it down. And then this is to maximize it horizontally. Move it left and right. Now press cursors and then press to select X1. We said we'll put X1 at the very top. Here's X1 moving. Then X2 at the very bottom here. Then we'll read delta Y, which is 1 point. So delta Y is 1.59. 1.59 times 0.632 equals 1. So we'll move X2 until delta Y equals 1 or negative 1. Now delta X is tau. So tau, we got tau here is 1.98 and the expected tau for this circuit is 1.84 and it's close to this tau. This is for the circuit.